Let's have some fun with service workers. First of all, small introduction. I'm Antoni. And I live indeed in Amsterdam, but I'm from Mallorca. And this is my GitHub and my Twitter. I'm not really active, but you can always find me there. And yeah, I work in a Dutch company called Non-Dutch. We do mainly front-end. But it's an outsourcing company, so I work every day at bol.com, which is, you could see it as a small Amazon of the Netherlands. And this talk is about service workers and my journey on what happened when I wanted to put them in production. So yeah, let's start. What are we going to see today? Why is caching important? So why is this talk being done at all? We are going to have an overview of the cache technologies, so what's available nowadays. And then we are going to have some best practices on HTTP cache and a lot of cache strategies on service workers. So let's start. Why is important? Well, I think you all have seen these numbers. You will lose half of your users if your site takes more than 3 seconds to load. But on average, on 2G networks, the first round trip is already 3 seconds, so you're kind of already fucked. And more important, it takes quite a lot to load only 1 megabyte. So because of this nightmare, caching is important. So the best performance improvement that you can have on loading, actually, or currently on all the browsers, is caching content on the user's device. So the goal is to avoid hitting the network as much as possible, or not hitting it at all. So first, let's take a look to the spectrum of cache technologies. What's available there? On the minimal side, the lazy side, is the browser cache. So you don't do anything. You rely on the browser to cache things and speed it up for you. So things like memory cache or setting up HTTP headers or new caches that are coming up like the HTTP2 push cache. So you can send resources to the browser before the page requests it, and when the page request is going to hit this cache. It's great. It's what we got for free. Then you get optimized browse cache. Is what I think most of you are doing today, or what you should be doing. It's things like link, rel import. It's just try to preload stuff before it's required, so the user will see it fast. It has some proactive page load improvements, but still it's quite weak. Then on a good side, we have content caching, which relies on mainly 2 technologies. The cache storage, so you can use the cache storage API even outside the service workers. We are going to see an example of it. And for structured data, the IndexedDB. It's almost on every browser nowadays. So if you follow this kind of logic, if it's URL addressable, you can store it in the cache storage. And if it's structured data, you can store it in the IndexedDB. And this will give you already a great performance. For instance, you could cache in the IndexedDB the state object of your React application or Angular application, and when the user comes back to your website, will have the state where he or she left it. And it's quite, performant, and is not so complicated to set up. And on the right side, we have the bleeding edge service workers. So what's the best and more granular cache technology available today, with the plus that is available also offline. So if we look at this spectrum from several perspectives, we could see the time that you have to invest for it. And it goes from 0, because it's for free, the browser does it for you, to little time or a bit more time for content caching. And then we go to full cache control. The service workers will take you a lot of time. You have to design well your cache strategies. But the benefit is also going to be really good. So you have to keep this in mind before going to develop anything. About predictability, the first two technologies are kind of unpredictable because you rely on where the browser stores the resources for you, and when the browser decides to delete it, that's it, and you cannot control it. On the content caching, you have more or less good content predictability because you can store whatever you want in IndexedDB and on the cache storage, but you still depend on the URLs. So you're kind of, it's a half-half here. And with service workers, you have full control. It's fully predictable. You decide what to delete or what to cache and when. Granularity. This is really important. When you cache something, you want to be able to divide your website in small pieces and decide when to update something to don't download everything. So as much you can break it in small pieces, the best, because you could update only the small pieces and not the rest. And we see that with the first two technologies, well, it's not possible. You have to update the content per URL. On the content caching is quite good because you can have IndexedDB migration and this kind of stuff, but you still depend on the URL, so it's 50%. And with service workers is, yeah, it's just full control, so you can decide when to delete things. Yeah, the two first technologies work only for network response, and content caching and full cache control, it's all response types. So ideally, you as a developer, the sweet spot is between optimized browse cache and content caching. This is the best return you will get in performance with the time invested. But this talk is about the other two, the full cache control and the browser cache with HTTP headers. So let's take a look. One thing you will be wondering right now is how much space do we have on the browser to store things? Well, different browsers have different policies, but according to Google, in research that they did in 2016, you can count with 50 megabytes of persistent storage on all devices, so mobile devices and browsers. But it's going to be the case in a lot of browsers that you get more space. And how reliable it is. Well, the browsers have browser eviction strategies, but what they try to measure, like Chrome and Firefox, they try to measure, okay, your site is used recently or often, so we are going to try to delete your site the last of them. And Safari and Edge, they never delete it, which you can think, oh, that's a really good policy, but if you realize it's not so good because this means that the storage will be full and the user is going to delete everything, so you're going to lose all the information. And on what's coming to make this better is the persistent storage. Is a new API that you will be available to subscribe, and the browser will ask to the user, hey, the storage is full, which websites do you want to delete your content from, what you don't like, and if the user likes your site, he or she won't delete this information. So this is great. Okay, let's start with the HTTP cache best practices. There are mainly two patterns. The first one is setting a really long max age for content with a specific URL. So the browser and the CDN and all the network intermediates can cache it and store it for the time that you say in max age, seconds. But the con is that if the content changes, you must update the URL. And well, to do this, usually you have your scripts with some version or hash of the build or the date you created it. So this is great for content that you can change. You can change the URL when the content change. One important new technology is the immutable extension. This can save a lot of time loading, or what happens when the browser reloads your page is that the browser has to guess for each asset if it's reliable what is cached, or if it has to revalidate it with the server. With immutable, you are saying this is never going to change. And well, with some test from the Facebook people, it looks like just with this small detail, you can save or improve the speed of load of Facebook by seconds. So it's something to keep in mind and try to use it if you have content that is never going to change, such as images or logos. The pattern one looks great, but is not really friendly with content that updates often, like an article or things that you need to update, and they cannot change the URL of your site. So this is why we have pattern 2, which is mutable content server revalidated. So you use cache control, no cache. And what this is telling to the browser is that you first revalidate with me that this content is right, and if it didn't change, you can use what you have in your cache. So you save all the traffic of serving this asset. There are some things that you have to keep in mind, or some gotchas, is that no cache doesn't mean don't cache. It means you must revalidate with the server before using the cache version. And usually what you were looking was for no store, which means you cannot cache this asset at all. And must revalidate doesn't mean must revalidate. It means the cache version can be used if it's younger than the match age that you provided. Otherwise, you have to revalidate. Yeah, it's a bit of a gotcha side. And also, no cache is not the same as match age 0. You could guess, if I said my assets with match age 0, the browser is gonna revalidate them, but it turns out that this doesn't happen always. So if you read the specs and, well, it turned out that some scenarios can make the browser use your asset without revalidating. So if you want to be safe, use no cache. The pattern 2 is great, but it requires always a network fetch. And as we've seen before, it can take really long on slow networks. So the best is to combine them. So pattern 1 for immutable, pattern 2 for mutable content. And remember that an HTML page can have dependencies that are in CSS and JavaScript content. So think that when you change your page, you might want to update the CSS and JS, so the caches behind it. And if you're serving specific user information, use cache control private, so the CDNs and the intermediates won't cache this information. Okay, let's have a look now on the bleeding edge. What's a service worker? Service worker is it's a worker that is event-driven, so have some events that will wake him up, and is registered always between against an origin and a path. So your domain and the path that you want. It can intercept and modify network requests. Runs in a different thread, so it's not blocking the main thread. It's great performance. It's designed to be fully async and has access to asynchronous APIs such as IndexedDB. But you have to remember that for security only works under HTTPS. It's a worker, so you don't have access to the DOM. And you don't have access also to synchronous APIs, like local storage or XHR. Did somebody know that there is a synchronous version of XHR? Well, it's really old, and indeed, I discovered preparing this talk that is there, but it's been deprecated, so you can almost forget about it. How would look your first service worker? You have a set of lifecycle events to get from no service worker to service worker, and those are installed. If the installation is successful, I get activate, and you can then intercept a network request. we can see the code of this. I prepared a really meaningful demo app. Can everybody see the code? We are going to have here the Node.js server telling which resources are we serving, the Node, the Chrome DevTools, and this amazing website that, well, is really stupid and simple. I prepared it for the demo, but it has the main resources that a usual website has, so images, some fonts, and CSS, JavaScript, whatever. So if you want to add a service worker, let's add this service worker hello world. We register it in the root scope, and if we look to it, the only thing that is doing is being installed. So here in application, you have a specific part for service workers with some errors from before. So if I reload this page, you can see how the service worker hello world is downloaded and installed. So the install and activate events are being triggered. And now if I reload this page, all the fetch to the network are being intercepted somehow. So I have a console log there. Yeah, nothing fancy. Another thing that you usually want to do with the service worker is update it. So you just have to change the script, and the browser will detect that this script changed and try to evaluate if this service worker is redundant, so nothing really happened and I won't activate it, or if it has to be activated. So if we reload, now we will see that there is a new service worker and is waiting to be activated. This is because currently we are having a browser screen that is looking to the service worker. And usually the browser waits to activate your service worker until you close this tab to avoid the situation that you have two different versions of your website living in two different tabs. Because this is a worker, so imagine I have one tab here and I'm logging the fetch for this tab, but if I open another tab with the same app, I'm going to get also the logging here. So it can be that many tabs of your browser are working with the same service worker. And thanks to the developer tools, you can also see this here. So you can see the hello world that has these clients. And you can even focus on them. So you can know which screen of your browser is using this service worker in this moment. If you are really sure about what you want to do and you want to get activated soon, there is a great piece of code to it that is skip waiting. So if we increase the version of this and we skip waiting, when I reload this service worker, it will activate without waiting for the clients to be closed. Let's go back to the slides. So yeah, this is an animation of what I told you. The service worker gets active and is waiting until you close your tab to be active. Let's take a look to some more fancy cache strategies. So probably the first thing you will be wondering is, when do I have to store information? When is the best time to store assets in this cache? I would say that the small part or the minimal meaningful part of assets of your website should go on the install event, and you can make them to be a dependency. So for instance, we have this website that we require the fonts, and we require JavaScript, CSS, and well, the index itself. So in our service worker, install as a dependency, we can have a list of assets that are the minimal that has to be cached to this website to work. So the index, the CSS, and the JavaScript, and you make them you make the install event depend on them. What does this mean? This means that if we clear everything and we reload this website, we see that the website was loading all the assets, and after the website is being loaded and is rendered and everything works on your browser, then the service worker kicks in, because we don't want to bother the user or use the network until the web page is not working. And we start caching all these assets. So now if we go offline, sorry, I have to clean the browser cache. If we go offline and we reload, we see that the page is mainly working, but we don't have the images because are heavy assets that we didn't cache. What happens if there is something, if something goes wrong? For instance, I'm gonna ask the service worker to cache an asset that doesn't exist, and I'm gonna make this event depend on it. So if something goes wrong during the installation of your service worker, because it's requesting something that doesn't exist, or there is a network error or whatever, what is going to happen is that the service worker is going to fail to install, and this means that the web page will wait until the next visit to try to install the service worker again. So you avoid the users having a broken web page when they are offline, or inconsistent assets because they managed to load the CSS with a different version. But what happens with the images? You could also store things not as a dependency. So you could say, okay, it's really important that that I have the CSS, the JavaScript, and the fonts and everything ready. But on your install event, you could preload some images, but don't make the event depend on it. So for the site assets, or for the what's the minimal to make this version work, you make the event depend on it, but not for the rest. And this would make that if we clean everything and reload the page, and we go to the network tab, we can see that the service worker downloaded in parallel all the assets that, so the images, and also the minimal of them. So if we go offline, we are already fully cached. But this might not be the best place also to start doing things. Let's take a look. Okay, so there is a downside of the demo that I just showed you, and is that for the first visit on your website, you are doing this. You are downloading your website, then the service worker downloads, and you are downloading again all the assets. For things that never change, like the images, this is a waste of traffic. So you would probably want to avoid this. So you can make the HTTP cache and the service worker work together. To do this, you just have to set the right directive, header directives in your server. So if we change that for the images, we use a long match age or immutable content, and we restart the server. What's going to happen now for the first meaningful visit on your site is that the browser is going to request everything for the website, then the service worker kicks in, but for the assets like images, you are using the disk cache. So you are not asking them again to the server. So the images got downloaded only once, while the CSS and the JavaScript files got downloaded more times. It could also happen that you want to be sure that the browser is not caching your assets, and you want to be sure that you are hitting the network. In this case, what you can do is, well, there is a built-in technology in the request, which is an option called cache, no cache, but unfortunately is not available on Chrome nowadays. So what you could do is just have a simple cache busting mechanism. Like I implemented a function that simply what it does, and is really common, is add the date of today as a cache busting. So if we delete the caches and we reload again, we are going to see that the images are being requested with a cache bust parameter here. Is the JPG and cache bust. So you are sure that from your service worker, you go to the server and your resources are fresh from the network. Also, when to store resources. One of the events of the service worker is when you get activated, and this is a good time to delete your old caches. So imagine my website changed something, or we don't have this cat picture anymore, and I want to delete it from the user cache. So here, let's move to the service worker on activate. And I have here the activate event. And what we are going to do is, on one side, delete the old caches. So everything that I don't use anymore can be deleted. And on the other side, you could here prefetch some information that you are going to use later, or is a good place also to migrate your IndexedDB database. So you were using an old schema and you need something new, so you can do the migration here safely, because you know that that your service worker is in the latest version and your clients, so the websites, are going to use this version. So for instance, if we make this mechanism to kick in, we could have our application with the service worker and with specific caches. So we have the offline site version 1 and the offline images version 2. So one for the meaningful and the other one for the images. And we decide to migrate. We change something in our code, we change the version, and now what's going to happen is that when I reload this page and a service worker kicks in, let's skip the waiting. Here in the console, we can see that because the service worker got activated, we are deleting the old cache. So if we go to the application tab and we go to the cache storage, only the new caches are there. We deleted the old ones. Let's move on. Recently it came an interesting article about someone that published a really great book, and it's for free for everybody. And what is he doing is he thought, okay, so if someone visits my website, probably he wants to read my book, so I'm going to download everything. I'm going to download all the books, so if he's online, he can still read my book. And this is great, you would think in first time, but you are using 16 megabytes of the user device, and could be that the guy was only checking your book and is never going to read it. What's going to happen with these 16 megabytes? So one of the best strategies, and what's really user-friendly, is to ask to the user what he wants to do. So on your web page, you could have an event triggered by a checkbox or something that makes this article available offline. So, for instance, now these assets are not cached, so if we go offline, nothing is going to happen. But if you say, I want this available offline, what's going to happen is that we are requesting all the resources that are needed for this article to work, and we are storing them in the cache storage. And this looks something like this. Well, mainly we can go to the slides. It's just, oh no, I don't have the code for this, sorry. If we go to Grumpy Cat, the index HTML, when the user marks to store the assets, we send a list of assets that we want to cache. We say the name of our cache is the offline Grumpy Cat, and we send all these assets to cache. And when the checkbox is unselected, simply what we do is tell the cache to delete everything of our offline Grumpy Cat. This brings us to another point of the presentation, that is that the service workers can share the cache. So imagine that you are developing in a big company a big website, and you have different, let's say, different parts that depend on different teams. It could be that the team for, I don't know, for sending products wants to cache things differently as the team for invoicing. What you could do is register several service workers in different pages and allow them to use the cache stored previously by another one. So when we go here to monkeys, we change the scope, and there is a service worker registered on this scope. And what this service worker is doing is to cache everything that this page needs to work. But if then from another side, so the main page, we use an asset that was cached before by the service worker will open the cache and will find this asset and won't need to go to the network. This is great because you could decide by different teams how they cache different stuff, and just don't have to worry, just rely on them. So this is the piece of code that makes it work. Instead of opening your own cache, like my site, my version, you just open all of them, and for your domain, we'll find which assets you have cached. Another strategy is for resources that update frequently. When the page requests them, you go through the network and you update your cache. So you are sure that you have in the cache the latest version. So if the user goes offline, you can always use the latest. And this looks something like this. So you do the request, and when the network request is successful, you update the cache with it. Another strategy, if you want to be fast and doesn't matter if you don't have the latest resources, is go first to the cache. So the browser requests something, you go to the cache, you serve it, and on the background, you go to the network, you get the latest version of it, and you update your cache with it. So when the user goes back to your website, it will have the latest version. So if it's not mandatory to have the latest version and you want to be fast, this is a great strategy. And it looks just like the opposite as before. So you return what's in the cache first, and then you fetch something from the internet. And you could also have your service worker downloading or caching stuff on a push notification. So for instance, imagine that you are building a webmail, and your web application like Gmail receives a push notification that you got a new email. You could ask the service worker to download all the resources that this email requires to be displayed. So you are sure that when the user goes to open this email, it's going to see immediately all the email without having to wait for the network. And this looks more or less like this. You add this event listener to a push notification, and you detect that is the push notification with your name, and then you download the assets that it asks for it. And this is something that is coming. Some browser makers and even operative system makers want the service worker to don't be dependent of the browser, so more on the operative system level. So you could send a sync on the background event and make the service worker to update the cache with some resources. And this is great for things that are not urgent to update, but that is great. Like for instance, you have a calendar application and you received a new event. You could say, okay, try to download the details for this day, and if you succeed, it's great, and if you don't succeed, well, next time when the user loads the page, we'll go there anyways. Also, what you could do is do things when the request fail. So for instance, you could go first to the cache, and if I don't have a resource, then go to the network. And this is what you usually do when you want your website to be offline first. You could do the other way around, go to the network for the freshest resource, and if the network is not there, if you're offline, just serve whatever you have on the cache. It's a quick fix for frequently updated resources when you are offline. And another interesting one is the generic fallback. So you try to go to the network or to the cache, and it's not there. I don't have anything on the cache regarding this resource, and I don't have anything on the network. On the service worker, you could decide then what to show. And I have a demo about this. So for instance, let's leave it open here. Here in the fetch event, I have a code that is calling a function that decides what to do when the resource is not there. So I clean my storage, I get the latest service worker, and yeah, for instance, now I'm sure that my website works offline. But imagine that something happens and the user decides to go to a resource that doesn't exist, like blah, blah, blah. You could have this, like you could serve an HTML saying, sorry, I don't really know what happened, or I don't really know what you were looking for, but at least it's a meaningful message. It's not the typical error page or a 404. You could even have something funny, like a video game, like, I don't know really what you were looking for, but here's a video game, you can play with it. But you can also detect what were you looking for. So for instance, if instead of going to a specific page, what you did is request an image, something like, let's make up a name, something like this. You can have the service worker to detect on your headers that what you want is an image, and you can have an SVG saying, okay, you are offline, I cannot serve this image because I cannot request it from the network. So this is useful when you want to be sure that the layout of your website won't look really bad because you have the typical icon of asset not found. So yeah, let's move on. Panic time. What happens when you decided to go for service workers and you say the cache control must H immutable on all your JavaScripts because you are using HTTP headers to cache things for browsers that they don't have service workers, but you also want to be the bleeding edge and you are using service workers. So you can find yourself in a situation that what guarantees that your cache is up to date, which is the service worker, is cached. So you are not able to update it, and you can think, what do I do now? So don't worry, because by standard, the service worker must be revalidated always after 24 hours. This means that even if you say the service worker is never going to change, the browser is going to try to revalidate it. It's not going to respect the HTTP headers that you set, and it's going to be sure that you have the latest service worker. This is great for panic time in production. Some useful resources, because we are heading to the end of the talk. Usually I check, of course, everything that Jake Archibald tweets or publish. It's a great guy that is pushing the standard forward. But also there is a great book, Service Workers Receipts, with a Git repo. And it's a cookbook about different strategies, even more than the ones that I showed you here. So yeah, you can just download it and check out what's there. And also this GitHub repo created service worker list with a similar offline receipts. And there are some libraries to help you put in the service worker in production, such as service worker precache, or there is even a plugin for Webpack if you want to just plug it in your pipeline and deploy it. And yeah, we are heading to the scary part of questions. Who does have questions? Sorry? Yeah, so good question. When you register your service worker in for instance, index.html, you're saying navigator, register this service worker, which returns a promise, but you could here in the catch, you could implement a catch and say, okay, this failed, and you could get some feedback about why it failed, and you could just do things there. And on the success, you can also get some feedback, like you could see where this service worker is registered, like the scope, and some information like if was existing before another service worker or things like that. More questions?
Yeah, just raise your hand if you have any question. Just don't be shy. Okay, cool.
Is it possible to register multiple service workers with scopes that match each other?
No, so when you are trying to register a new service worker or two service workers at the same time with the same scope, there is an event that is going to happen, and is that the browser is going to detect that this service worker is redundant, so you have something already for this scope, and it's not going to install it. So you won't have two service workers active on the same scope of your domain.
How to test service workers?
Sorry?
How to test service workers?
Good question. This is something that I don't really know well how to answer. What we did in my team is to have a fake browser that, some tests on Chrome that download the assets and checks on the network what was happening. But yeah, it's something that I didn't take a lot of look.
And what about course requests for fetch inside service workers? Does they work well?
Yes and not. It's possible to do a foreign request, but then you run into some interesting stuff.
What about options request for cross-origin domains?
So the thing is that most of the times what you will have is a response with, so in the request, as I showed before, you have an option to say no cache, but you could set an option to no, let me check it out. Well, you have a specific setting for cores, but what you are going to get is an opaque response. So it's a bit of a flaky field because you cannot be sure that it's a successful response. So I'm not sure if you should cache it, but it's possible to do a foreign fetch.
Кто-нибудь еще может? Well, okay. Thank you, Anthony. Just.
Thanks.